Hello and welcome to this section, using Ansible with cloud services and containers, followed by the first video in this section, AWS with Ansible. This section is quite a light one, but we look at two very exciting topics. First of all, we get started with AWS with Ansible. Then we look at how we can actually use Docker with Ansible. Please join me in the first video of this section, AWS with Ansible. In this video, we're going to look at how to configure Ansible for AWS support. We'll create instances through Ansible with AWS and we'll allocate IP addresses. We'll make use of the AWS dynamic inventory. We're going to spin up our web app on scale across 20 hosts using AWS. And lastly, we're going to terminate and remove our AWS instances and related components. In this video, we're going to look at how we can use Ansible for the automation and deployment of instances in AWS. The modules within Ansible for AWS are built using the popular Boto and Boto-free Python libraries, and therefore, there's a lot of functionality for AWS as a result. For this section, you will need an AWS account. Amazon at the current time offer a free tier that can be used for this. If this is not available, I suggest reviewing the associated costs and becoming aware of the pricing structure. For the tasks that we're doing here, there should not be a substantial cost involved. Just to note, if you leave instances running, you may find yourself with an incurred cost. If you're new to AWS, research the pricing costs and also look into how you can actually set up budgeting alerts. Okay, let's get started. We're going to go to the AWS control panel. And within the control panel, we're in the EC2 dashboard. And as you can see there, we currently have no running instances. First up, we're going to create a key pair, which can be created here underneath key pairs. We go to the top right corner and we choose Create Key Pair. We're going to name this Ansible. And we want this in the PEM format as we're using this with SSH. And as you can see there in the bottom left-hand corner of my screen, it's automatically downloaded the PEM file. So keep that safe. Next thing we need to do is create an access key so that we can have API access to our account. So we're going to go up to our account settings. And we're going to choose My Security Credentials. And what we need to do here is create an access key. So click Create Access Key. And what we need to do here is save the information. As it actually says on the screen there, this is the only time that the secret access key can be viewed or downloaded. So let's actually click this. And I'm going to save this information. You need to be extra careful with this information as it essentially provides API access to your account. I'm showing here an access key that I deleted after creating this video, hence why I'm not concerned about the sharing of these details. You, however, should keep this information as safe as possible. We should have a default VPC that we can leverage, but if not, we can recreate the default one. Go up to Services and search for VPC. Click VPCs. And within this, I've actually got the default one there. If for any reason you haven't got this, you can easily recreate this by going to Actions and clicking Create Default VPC. The Ansible AWS modules use Boto And correspondingly, we need to have environment variables set up with the AWS information that we saw for the access key. So I'm going to do this for the values that I just created. Okay, so at this point, you'll be entering your own security details. And in this revision, revision 1, our playbook creates our security group for this project. If we take a look. Okay, so this security group configuration, we're specifying that we want port 80 open for the web server and port 22 open for SSH access, so that we can configure our newly created virtual machines through Ansible. If we were to run this right now, this would fail, as we don't have Boto installed within our system. Let's fix this first. And then we just enter the password of password. And your output might vary here, depending on whether or not Boto is already installed in your environment. Ultimately, at the end of this, as long as you have Boto and Boto free installed and the supporting libraries, you'll be good to go. Okay, there you can see mine are already set up, as I've actually done a trial run of this video before just to make it as good as possible for you. But on your system, you should actually see that collecting and installing Boto. Okay, so now if we run our playbook, okay, great. We can see that that's actually created the security group in AWS. If we take a look, and then we just refresh this page. Excellent. We've got an additional security group named Ansible. And within that, it's got 2 permission entries. Okay, let's create some instances here. If we go back to the EC2 dashboard, and then we choose Launch Instance, and then select Launch Instance there. Okay, you can actually see that there is this Red Hat free tier eligible Red Hat Enterprise Linux 8, which will suit our requirements. So we need this reference for the AMI. And depending on when you're actually watching this video, this may vary to what you actually see. Amazon are regularly updating their images, and if you actually want to have the latest version of their Red Hat Enterprise Linux 8 image, then you may want to actually copy that reference. Generally, from experience, I've found that even though you might not actually see the version that we're using in the examples on the page, Amazon do keep those images available. So these playbooks should actually work with no modifications. Okay, so let's go back to our terminal. And we're going to step into revision 2. If we look at our example now, you can see that we're requesting the provision of a set of instances. The instance type we're specifying as t2.micro, then we have the image ID, and we're using the US-East-1 region. We're registering the output in a value called EC2, and I know ahead of time here that within this, EC2.instances will be a list with all of our instances, and within each of those, there will be a public IP. We'll use this to dynamically create a group in Ansible with all of our AWS EC2 VMs. The last thing I want to show here at this point is the instance underscore tags, where we have the name of Ansible. And this will make sense later on as we actually go through these examples. Let's run this. Okay, great. I sped this up for the purpose of the video, and you can see there our group listed at the bottom. with all of the IP addresses of the instances. If we look in AWS, we should now see these within the EC2 console. Okay, great. So they are running and you can actually see those are just going through the status checks. Okay, so if we go back to the console, and if we were to rerun the playbook, it's going to fail now on the instances. This is a nuance of the module. Technically, we're not asking for more instances than we've already got, but it will hit the instance limit exceeded error first. We can get around this quite simply with the ignore underscore errors keyword. So if we go into revision 3, you can see we've got the addition of that option. If we run this again, we get a bit further, but because we haven't actually created the instances, nothing has been registered in the EC2 variable, and as a result, our next task fails. So this here is not a good approach. A better approach is for us to use a dynamic inventory that relates to AWS. Fortunately, there is already a dynamic inventory available for our use. There is also an associated ini file you can copy to etc Ansible, or, as I'm doing, you can set an ec2 underscore ini underscore path variable to the location. When we actually set up the inventory, we're also going to change a default caching option, which is standard on the AWS dynamic inventory, which will cache API information for a certain amount of time. As we're going to be doing a lot of changes in succession, we don't actually want it to do this, but it may actually be of use for you if you are using this in a production environment. Go into revision 4, and if you're looking at your version, you'll already have these files available, but I'm going to show you from scratch how you actually get them and how you would actually set them up. Okay, so we're going to do a make directory for the inventory. And let's change to that directory. And we're going to download the Amazon dynamic inventory. Okay, great, that's done. And we need to download the ini file, which is exactly the same again, but .ini instead of .py. Okay, and let's make our inventory executable. We're going to make some minor changes to this file. Okay, so first up, in our environment, we are using Python 3 specifically, so let's change that on the end there. And there is, at the time of writing, an issue in this version, and it's quite easy to actually resolve. If we go to line 172, and we just hash this line out, and then we save that file. And let's edit the ini file. And then we search for cache at the start of the line. And this is the one we want there, cache max age. We're going to change this to 0. Then save that file. Okay, and then we go back one directory. And what we're going to do is we're going to set the ec2 underscore ini underscore path variable that I spoke about. Okay, if you recall back to the lesson that we did on dynamic inventories, a dynamic inventory is quite simply an executable file, and we can actually run this with options like -- list. Let's give this a try. And we'll pipe that through to more. Okay, this takes a while to run, but once it gets there, we can see a lot of information here. And you'll notice it's using the underscore meta approach that we discussed earlier to list all host vars at once for performance purposes. If we were to go through the output, there's a lot of good information there. One thing I want to bring your attention to in particular, I'm going to search for tag underscore name underscore Ansible. And you can see that this relates to the tag that we applied upon creation, and this means that we've already got a group that we can easily target all of our machines with. There's going to be a little bit of work that we need to do to be able to target these, so I'm going to just press Q to quit out of this. And first up, if you have a look at the ansible.config, you can see that the inventory has been updated to point at the dynamic inventory. The number of forks has been increased to 20 to correspond to the number of hosts that we have. And we've also got our Ansible underscore managed key in there. We would need a group vars for the group that we actually referenced there of tag underscore name underscore Ansible. And there's one already prepared for this. And you can see here that's making reference to a private key file. It has an Ansible user of ec2-user and the Ansible become is true. So what we need to do is make sure that we actually set up that file. So I'm just going to edit that here. And we're going to copy the content of the file that we actually saved earlier. And we'll just paste that in. And we need to set the permissions accordingly. Okay, let's now check that these are pingable using the Ansible ad hoc command line tool. So this is going to be Ansible, the name of our group, the module we want to use is ping, and we'll use the one-line option. Okay, perfect, that's worked really well. Okay, and if we take a quick look at our playbook, you can see there at the bottom we have our roles to install the web app role, and we have a target directory of user share nginx HTML. And just a note, in the background there are some minor changes to the template to accommodate the variances in Red Hat. So there's a new Red Hat logo added to the logos YAML file, and within the template we have another check which is actually checking for the Ansible distribution, and if it's Red Hat, it's using the Red Hat logo. Let's give this a try. Okay, brilliant. So if we actually pick one of those, so I'm just going to pick this bottom one, and then we browse to that in a web browser. Okay, perfect. We've got our page, and technically now if we actually click this, we get our Easter egg. Okay, that's great. So let's actually move into revision 5. And in this revision, we're adding a simple prompt telling us to check the instances before what will be the next step of us clearing down the AWS environment for this. Let's give this a run. Okay, so there we've got our prompt, and we can pick any one of those. And again, that's working as expected. Okay, I'm going to press continue to terminate, which it won't actually do at this point. But now if we go into revision 6, and we've got some additional tasks there. So what we're doing is actually removing these instances from the security group by setting it to an empty security group. We're then terminating. And lastly, we're removing the Ansible security group. Let's run that. Okay, at this point, because we checked this previously, I'm just going to continue here, and we'll see if it cleans down accordingly. Okay, great. Those instances are terminated, and it's removed our Ansible security group. Let's just take a quick look in AWS. And if we refresh here, we don't actually see any instances. Let's remove that filter. And there we are. They're all terminating. So now from this point, if we want to, we can run our playbook again, and from scratch, it will create our instances, install our application, wait for the prompt, and terminate. As I mentioned previously, I want you to be careful that you don't accidentally incur any costs with this. So after actually going through this lab, please check over the EC2 dashboard. And after that's actually completed terminating, make sure you actually haven't got any items left over that you're going to be charged for. That's it for this video. I hope you enjoyed it. Please join me for the next one, Docker with Ansible.